if you have a red, I'm going to use a red pen at times and some highlighters, so if you have it ready to go. Okay. Okay. Finding the equation of the axis of symmetry. Since a parabola is symmetric, I don't think that's a surprise anymore. Points on either leg are equidistant. What is that, right? Same distance, right? So from every leg to the center, it's the same distance from either end, right? So equilateral, equidistant from the axis of symmetry. Okay? If you're given 2 points that have the same y value, that's very important here. That's worth highlighting. Okay? If you have 2 points and they both have the same y value, and I want to make clear you understand, if you have 2 x-intercepts, what are their y values? Both of them. X-intercepts, 0, so they have the same y value as well. Sometimes students don't think of it. X-intercepts like a different category. No, this have a specific name, but y is equal to 0. So they would also have the same y value if you're given 2 x-intercepts, all right? They are the same height. They have the same height, right? Same y value corresponds to them being like at the same height when you look at the y value, right? We can find the value of the axis of symmetry using, watch this, this is the big formula. X is equal to x1 plus x2 in brackets divided by 2. And I always want students to understand the formula, so I will explain that to you, where X stands for axis of symmetry, right? It's basically the X value of the vertex. X value of vertex, remember that, right? And then the x1, X value of first point, x2 is the X value of second point. And if you think about it, that's basically the average, right? If you have 2 numbers, you add them up and you divide it by 2, you're finding the average of the 2. Think of it that way. So let's put it to the test. Let's give you a visual on this one. So I'll try to keep that on the screen. But here, let's say, determine the equation of the axis of symmetry of the parabola below. Use both sets of points, right? So when you're looking at the axis of symmetry, in this particular case, we can actually tell already what it's going to be. Right? We can see it, but let's just go to the vertex, make a big dot right there, and just draw our axis of symmetry. I would say it's considered an imaginary line, right? That we consider that shows us where the symmetry is, the line of symmetry. And so the vertex has points. In this case, we would say if this is the origin, it's 2, 3, right? We know that the axis of symmetry is 2 in this case, but we're going to do it mathematically because chances are you're not going to be given a graph, right? I'm just going to give you 2 points. So there's the right leg and the left leg in this case. And so notice these 2 points. Green is not a good choice. just ruined it. Let's see, orange. My green is not the best choice. So that's a 5 though. Okay. That's a 5 and this is a 5. Okay. So they have the same height. So if you have, I'm going to use a blue pen in my case or something. I'm just going to make a line connecting these two. Okay. And I know that this distance is the same as the distance from the center to the other leg. Like if you're on either side of the leg, it's the same distance to the center every single time. Okay. Same with those two up here. I just chose 2 points up here. That distance is the same as the distance here, right? In this case, we had 2 units, and so it's also 2 on this side. In this case, it's 4 units. It's also going to be 4 on this side. And I will also point out that in this case, both of their y values are also the same. Okay. So let's see here. If you use these 2 points here, okay, using -2 and 11 and 6, 11, okay, you notice that they both have the same height. Okay, so we make this our x1 and we call this our x2 here. Do you remember x1, y1, x2, y2 to find a slope and stuff? Same idea, but we're just interested in the x values. So to find the axis of symmetry, we would go -2 plus 6 divided by 2. -2 plus 6 is 4. Divided by 2 is 2. Okay, this is over after. So the axis of symmetry is 2, which we knew, right? Look at this. Our vertex has a 2 and same here. What if I use these 2 points here using 0, 5 as well as and 4, 5. We call this our x1, call this our x2. The axis of symmetry would be 0 plus 4 divided by 2, and you know where this is going. So we're just confirming what we already knew, right? The axis of symmetry. So we can now confidently state that the axis of symmetry on this graph is the line x equals to 2. Okay. So make sure you use the same color for all the axes of symmetries that we've calculated and are shown on the graph. And how is this useful? How is this useful, you might ask, right? It will allow you to find a third point if you only have 2 points. Because how many points do you need for a regression? You need 3, right? So we're going to use this property quite often to find our third point. Okay. So very, very helpful, very useful. Real quick, let's find our axis of symmetry with these examples here. So if you are given 2 points here, okay, what's the axis of symmetry? The first thing that should stand out to you is like, hey, they both are 7s, which means it must be that they're on either side, on either leg at the same height looking at each other, right? And they're trying to find out where's that center line. Well, we call this x1, we call this x2. And so you should make sure you have that formula on your study sheet, right? So axis of symmetry would be -4 plus 5. It could be that you're adding two negative numbers, so watch out for that. Divided by 2. That gives us -4 plus 5. That gives us 1 positive over 2, right? We could say 0.5. So the axis of symmetry, it's usually, we call it that, but it's really, we're calling for the equation of the axis of symmetry, which is 0.5. And there we go. Do we know the vertex? In this case, we don't. We don't know the vertex, but we do know the x value of the vertex. We know that if we had to come up with the vertex, that half would be the x value. We don't know the y value. That's a story for a different day. Don't worry about that today. Let's keep going to page 12. You're like, what about this one? It's the same thing, right? Like, we're doing the same thing. We're adding and dividing by 2, so I'm just going to leave that one. I have more examples that I need just in case, right? If I ever review, I'm like, hey, let's do this one. Let's keep going. Page 13. Determine the missing x value. So you're like, okay, there's 3 points. How is this important, right? Well, I would say that this right here, what is that? What do we call the x value of the vertex? That's also our axis of symmetry. So we know that in this particular case, the formula, right, x1 plus x2 divided by 2, right? We know that this is 6. This one right here is 6. Can I just put next to axis of symmetry, I'm just going to say this is x. Right? And then this one here, it doesn't matter which one you call x1 and x2, you just have to be consistent. This is x1, and this is x2, which is unknown to me, right? I don't know what x2 is in this case. So let's see what we can do with this formula. I'm just going to box this in and say, hey, I'm going to use this one. 6, I'm going to substitute that in. x1 is 3 plus x2 divided by 2. We're almost ready to do our regression, but we need a third point. We need the coordinates of this. And so I'm going to use that. So here you do a little bit of algebra here. To get rid of this 2, that's dividing the whole thing, we multiply the whole thing by 2, the whole thing by 2. That's going to be the case every single time. So this just cancels out. 2 times 6 is 12. 3 plus x2 is what I'm left with on the other side. Then I want to subtract the 3 because it's adding here. So x2 is equal to 9. So you actually now found the x value of that point, the third point, right? Therefore, 9, 5 is the third point, right? Are the coordinates of the third point. We use a highlighter here and just say, remember we were missing x2, and so now we found it, and there it is. So now we could technically perform a regression because we have 3 points. Okay, we're gonna skip what I had there underneath this one here. Just gonna leave, or did I assign that? I'm not sure if I assigned that at one point. We're gonna leave that, and now we're gonna skip forward, and we're gonna use this. So we're going all the way to like, what is this, page? I'm gonna take you to page 49. Yeah, I'm take you to page 49. Now we're gonna use regressions with word problems. Okay. I'm about to dive into this one. There's a domain and range question there on page 47 that I might assign after today. So let's keep that in mind.